Hey there. So today we're going to talk about mirrors. In our last lesson, we talked about light, and we talked about the wave using the wave speed equation as it applies to light. Now, in the next couple of lessons, we're going to talk about reflection of light, and that's where mirrors come in. Today, we're going to talk about plane mirrors or flat mirrors, and in the next lesson after this, we're going to talk about curved mirrors. And so, our target for today is to be able to explain and predict reflections in flat and curved mirrors. So let's go ahead and talk about flat mirrors. There you go. I'm holding my face in my hand. It's kind of creepy. Pretty cool, right? Okay, so a flat mirror or a plane mirror is really just the kind of mirror that you're pretty much used to. You probably look in one every morning before you come to school. Some things to understand about plane mirrors. Oftentimes, we'll draw what's called a ray diagram to represent how light is being reflected in a mirror. And the ray diagram helps us be able to understand and predict what kind of thing we're going to see in the mirror, right? There's a couple of rules that help us to draw these ray diagrams. So let's talk about some of the things we need to know about it, some of the terms, and then we'll draw some ray diagrams, okay? So one big idea in reflection with a flat mirror is that the light striking the mirror will reflect off at the same angle. Okay, there's a diagram here. Oftentimes you'll hear people say the angle of incidence equals the angle of reflection. And what this means is that if we were to draw a line that's perpendicular to the mirror, right, at a right angle to the mirror, we call this a normal line. Why do we call it a normal line? Well, normal means perpendicular, right? So this is a normal line perpendicular to the mirror, and then we were to measure the angle that the light comes into the mirror. We call that the angle of incidence. Measure the angle between that ray and the normal line. It will reflect at the same angle on the other side of the normal line. So the angle of incidence equals the angle of reflection, right? Beyond that, there's a couple of terms that we need to be aware of. Okay, I'm going to put a diagram up here, a diagram of a ray diagram. A diagram of a ray diagram. You know what I mean, okay? A few words we need to be familiar with for the things in a ray diagram, okay? You can see in a ray diagram, you can see a picture of the mirror. The mirror is kind of edge on, right? It's kind of like a line down the middle. You can see the object that we're putting in front of the mirror. In this particular case, it looks like a can or a bottle of some kind. The object is called the object. And its distance from the mirror is called the object distance. Okay? On the other side of the mirror, behind the mirror, we have what you call the image. So the image of the object is called the image. And the distance that it appears to be behind the mirror is called the image distance. Now, of course, there's nothing behind the mirror. This is just a reflection, but this is what it looks like from the other side of the mirror. Okay. Oftentimes, the object distance, we'll put a D with a little subscript O for object distance. And for the image distance, we'll put a D with a little subscript I for the image distance, right? And for a flat mirror, this won't be true when we talk about curved mirrors, but for a flat mirror, the object distance and the image distance will be equal, so that the image will appear to be the same distance behind the mirror as the object is in front of the mirror. Okay, now let's go and let's draw a ray diagram, and you'll see how to do it. It's really not that complex. All right, when we draw a ray diagram, usually you start by drawing the mirror, right? So let me draw just a line representing my mirror. So there's my mirror. Okay. And then usually, we draw a ray diagram with respect to where an observer is. So somewhere, wherever the observer is, we're going to draw, maybe we draw an eye, maybe we draw, just something to represent whatever's looking in the mirror. So somewhere over here, wherever my observer is, say, I don't know, right here. I'm going to draw an eye. That's my observer. Okay. And he's looking at something in the mirror. And what's he looking at in the mirror? I don't know. Oftentimes we'll draw like a pencil because it's got a different shape on one side than the other. All right, so somewhere in front of my mirror, I have a pencil. And there's my pencil. See, it looks different on one side than the other, so that, when I draw it on the other side, you'll see. Okay. Now, when we draw a ray diagram for a flat mirror, usually what we like to do first is we'll take our object and we'll draw it the same distance on the other side of the mirror. Now, this won't be the object. This is the object. Over here, we're going to draw the image. Okay, and we like to do the same distance on the other side of the mirror. So I'm just going to kind of take my ruler to the metric side. And this is about 44 centimeters from the mirror. And I'm going to make it 44 more centimeters. So right about there. Okay. So from the top of my pencil to right there corresponds to that point. This will be the top of the pencil. And let me do the same for the bottom of the pencil. Like 44. Right about there. Okay. So it should be something like that. Okay. Now, I'm not a great artist. Ideally, I would have drawn it exactly the same, but yeah, that's fine. I put the word image over here. That's okay. All right, now what we do is we're going to draw some lines from the observer to the object, okay? They kind of represent how the light moves in these cases. What I'm going to do is I'm going to line up, I'm going to cue up a line from the observer to the top of my object, or to the top of the image. Okay. And I'm going to draw this line, but I'm not going to draw it all the way to the image. I'm going to draw it to the mirror. And then past the mirror, I'm going to make it a dashed line. I can hold the ruler straight up here. Then hopefully it'll come out straight. That's good enough. Okay? And then from this point where the line intersected the mirror, I'm going to draw that back to the corresponding part of the object. So since this was the top, I'm going to draw it back to the top. So from this point, I draw it like that. So what that means is that the light traveled from the top of my pencil to the mirror and reflected back to my observer. But to the observer, it looks like the light simply came from over here. That's what it looks like. That's what it really was. And then oftentimes we'll do the same thing for the bottom of the object. So I'm going to cue up from my observer to the bottom of the object. And I'm going to do the same thing. I'm going to draw straight to the mirror and then dashed after that. And then from this point where the ray meets the mirror, I'll draw it back to the bottom of my object. So again, this is what the light actually did, and this is what it looks like the light did. And this is a ray diagram for a flat mirror. It's fairly simple. You'll notice a couple of things about a flat mirror, and these things will be different when we talk about curved mirrors, is that our image is the same size as our object. It is, it is right side up. It's not flipped upside down, it's right side up. This is what's called a virtual image, okay? Images that appear on this side of the mirror are called real images, and we'll see some of those when we talk about curved mirrors. Images that appear behind the mirror are called virtual images. So this is what's called a virtual image. And that is our ray diagram. So there is a little bit about flat mirrors and ray diagrams. Hopefully that helps us to be able to explain and predict reflections in flat and curved mirrors. Like I said, next time we'll talk about curved mirrors, we'll talk about concave and convex mirrors, and we'll draw some ray diagrams for those. But until then, take it easy.